We are the Smart Dog Collar team, here to present our project under Patrick Donnelly. Patrick Donnelly is a dog owner. He loves his pet dog Mabel, but unfortunately Mabel suffers from epilepsy, canine epilepsy to be specific. And one day, while Patrick Donnelly was at work, Mabel suffered from a cluster seizure that lasted about an hour, and as a result of this, Patrick was not able to be there to provide treatment quickly, and so Mabel had to be sent to a veterinary hospital and undergo extensive treatment, and as a result, unfortunately, suffered some brain damage, permanent brain damage. And Patrick wishes there was a way he could have known that Mabel was going to suffer a seizure that day so that he could have drove home and given treatment before it was going to happen.
Uh, Now, each member is going to introduce ourselves. I will start from myself.
Hi, my name is Hiroto Kazama. I'm an app development lead. As an app development lead, I built front and back end of the application. Backend development includes establishing connection to the Firebase platform to receive notification.
My name is Keenan Newcomer. I am the hardware lead. I got the Wi-Fi connectivity of our device working with the Arduino boards and a Wi-Fi microcontroller.
Hi, my name is Michael Chen, and I am the machine learning lead. That consisted of creating a model that was compatible with the Arduino and setting up the connections between sensor inputs, the machine learning itself, and sending it to other parts of the system.
Hello, my name is Earl, and I am the AWS lead. That has essentially been handling any of the in between the Arduino and our notification platform. So taking the data, processing it, and packaging it in a succinct, readable format for the notification.
This project seeks to develop a smart dog collar prototype that detects seizure in dogs. Leveraging this accelerometer and gyroscope data, machine learning models can be trained and deployed to detect seizures in real time. The collar will be connected to an app for the owner so they can monitor their dog's behaviors and receive notification of seizures in real time. This allows instant action to be taken to migrate the negative effects of a seizure.
From this problem, we can find important requirements that we want when creating this device. The first one, of course, is just a comfortable and lightweight device for the dog to wear. Patrick also wanted onboard machine learning, and then this device should detect seizures in dogs using relevant data that is meaningful. We also wanted the cloud to receive data from the product so it can dispatch notifications, and a mobile app for end users to receive push notifications when a seizure does happen. And so this is the overall results that we had, and so the structure of our project. And so first we'll start with the machine learning results. On the left side is the output of the Arduino's machine learning. As you can see, it goes between sleep and walk as I made movements with the device. And then on the right side is a confusion matrix, which pairs the actual versus the predicted. And that's based on the training that we did for the model.
And here is the current makeup of our device. In the picture on the left, the leftmost chip is the Arduino, and that stores our machine learning data and hardware that runs the machine learning algorithms. And to the right of it is an ESP32 Wi-Fi microcontroller, and that is what allows the machine learning data to be sent over the internet to our AWS cloud services. And then both of these are powered by a USB battery currently. Then I have the device physically here. And so I will connect it. It will start sending data automatically. And I don't move exactly like a dog, but I can attempt to, shake it around a bit or do some kind of movement with it and see if we get some different kinds of detected motion, like sleep or walking. I don't know if I can necessarily make it cause a seizure on here, but we can detect what the dog is doing, and it will show up in AWS.
Okay, that was hardware leading into AWS. So what we just showed was the pipeline from the device to the start of AWS. And so the main thing that happens for us is we pass it into something called AWS IoT Core. And IoT Core is just a way of managing Internet of Things devices, which Arduino falls under. We then use a rule to pass it into a Lambda function. And then that Lambda function will then basically pass it through a queue that then gets passed to S. So what you're seeing with the actual received messages were those being passed into the queue via the Lambda function. And so this way we can put into a FIFO queue to make sure that all the messages we are receiving are being received in the correct order and being dispatched correctly and accurately. And then from there, we go into our SNS topic, which is just their simple notification service platform. And so the idea with that is once we get the information in here, we can then put it into a notification platform application, which will link to our Firebase. And so this whole entire pipeline from the Arduino to here is the Arduino moves, it detects a seizure, sends that information up to AWS, goes through our Lambda, gets processed, goes through the queue, and then the queue outputs into SNS. SNS is linked to this endpoint, and then from this endpoint, the data is then sent off to FCM, or also known as Firebase.
Here's the example image of our running app on Android emulator. In the bottom of the screen, you can see the token sent to this app, and this shows that the connection from Amazon SNS through Firebase platform has been established.
So now we will talk about the future development for this project. So first is the machine learning. We hope to expand the current model inputs to better detect seizures. Something that could be used is potentially like heartbeat. We also plan to recollect data using the device we created to use for our model's training, because the data we collected was using a Raspberry Pi, but now we're using an Arduino, which might be very different. So we definitely need to recollect data to make it more accurate. And then we also want to test a theoretical predictive neural network that would be able to detect seizures well ahead of their occurrence. Currently, our device predicts if they're happening right now, but if they're able to detect it, if it'll happen in the future, there will be a higher chance that we can prevent them.
As for hardware, the future hope is that there will be the ability to change Wi-Fi credentials on the fly, which will make this device much easier to use for different users who have different Wi-Fi networks.
For application development, right now our app only checks if there's notification pending at the beginning of the start. In real use, we need to make an app that can receive notification all the time when running, or even on some background. And also, notification needs to show the full message instead of just a token.
Okay. Throughout the last 3 terms, our team has successfully built the pipeline infrastructure from sensors on the collar to notifications on the app. This infrastructure can obviously be built upon to produce a more complete and functional product. Some of the ways currently are likely going to be for data collection. Something that will be implemented is just a Dynamo database, so that basically anything that's passed through is going to go into a database so that it can be studied, figure out how to make the model better, feed it back in. For future, we expect the prototype we built to be used to study the usage of machine learning to detect seizures in dogs, and we really hope this technology serves as a breakthrough in the domain of treating epileptic